Okay, so initially we're going to have to find the domains of each of the functions individually. So to find the domain of f of x, because it's a radical function, we want to determine when this radicand is greater than or equal to 0. So we set up this inequality. 36 minus x squared is greater than or equal to 0. Now this is a quadratic inequality, so we can't just solve for x. It's a little more involved when you have a quadratic inequality. So the first thing you want to do is factor if you can. This is a difference of squares, so this factors to 6 plus x times 6 minus x. And the next thing we want to do is we want to determine when each of these factors equals 0. I mean, this is an easy step. You could do it in your head if you want, but if you want to work it out, you'd say 6 plus x equals 0. Solve, you get x is equal to negative 6. 6 minus x equals 0. Solve for x, you get x is equal to 6. So now we need these values here to kind of visualize what's going on to determine this domain here. So we start with the domain of all real numbers. So you know this is negative infinity all the way over here. This is positive infinity. So we want to break up this domain on these intervals. So we have negative 6. Our 0 would be here. We don't have to show it. I'm just going to show it, but it's not one of the values that we have to usually compute, because if we didn't solve for any of these factors to get that 0. And then positive 6. So what we want to do is we want to take each of the factors. So the first factor is 6 plus x, and we have a 6 minus x, and then together we have 6 plus x times 6 minus x, and this will tell us what's going on. So we've broken up our domain on these intervals, and we're just going to have to do a few test cases to understand what's really going on. So let's pick a value to the left of this negative 6. It can be any number you want. So let's say negative 10, and see what happens when we put a negative 10 in here. 6 plus negative 10 would give us a negative 4, and all we care about is if it's positive or negative. So all these values, so that tells us all the values to the left of negative 6 would give us a negative value. You put a negative 20 in, negative 7, no matter what, if you substitute it into this, it's always going to be negative. What happens if you put a negative value into this expression? 6 minus another negative number. So 6 minus a negative ends up being 6 plus. So that ends up being positive. So this last case is these two multiplied. So a negative times a positive means that that is negative. So now let's pick a value in between this interval from negative 6 to 6. We could use 0. That's an easy one to use. So if we put a 0 in here, 6 plus 0 is 6. That's definitely positive. 6 minus 0 is 6. Definitely positive. So a positive times a positive gives us a positive. And finally, let's pick a number to the right of 6. So let's do, I don't know, 15. 6 plus 15 is definitely positive. 6 minus 15 is negative. So now you have a positive times a negative is a negative. So remember, we're looking for when this expression 6 plus x times 6 minus x is greater than or equal to 0, or basically when it's positive. So that is this interval here from negative 6 to 6. But now we use the brackets because we're including them with this equals to. If the equals to wasn't there, we'd use parentheses. So the domain of f of x would be from negative 6 to positive 6, including both 6 and negative 6. Now we could do the same thing with the function g. But because this is a radical function, we want to know when this radicand is greater than or equal to 0. So now that gives us x plus 5 times x minus 5 when we factor. Let's see when each of these factors equals 0, and that tells us how to break up our domain. So this factor would equal 0 when x is equal to negative 5, and this factor would equal to 0 when x is equal to 5. And then we can set up our number line again. So we have -5, +5, and now we've broken up our number line on these intervals. So now we do test cases. We use one of the factors, x plus 5, then the other factor, and after you know both of them, you can make a determination about the two factors multiplied together. So we can choose values to the left of -5. That would tell us that -10, for instance, definitely give us negative here and also a negative here. So a negative times a negative would be a positive. Then we have something between -5 and 5. Let's use 4. 4 plus 5 is 9. That's definitely positive. But 4 minus 5 is -1. So then we have a positive times a negative, which is a negative. Then let's pick a value greater than 5. 20. That's definitely positive, and we have a positive times a positive equals a positive. So now the domain of this function would be the places where this multiplication resulted in a positive value, because that means it's greater than 0. And we have two separate intervals that we'll have to union. So the first one is from -infinity all the way to -5, including the 5 because of the equals to, union 5 to infinity. And we always put a parenthesis on infinity because it's not really a number, it just means it's unbound and it goes forever in that direction. So the three cases where we add f and g, subtract f and g, and then multiply f times g, they all have the same domain, and their domain is the intersection of their two domains. What we mean by intersection is where they overlap. So if we did a quick graph of both of their domains on the same number line, we can see where the overlap is. And then we'll talk about the division one after that. So here's my 0. Let's go out to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if we're just looking at the domain of the function f, it's from -6 to 6. So it would be to +6, and all these values in between. So this is the domain of the function f in red, and we'll use a different color for g. Well, let's use green, I guess. Okay, so now the domain of g says it's from one piece of it is from -infinity to -5. So it's -infinity is over here. So we include this, and then it goes in this direction forever. And then the other one is from 5 to +infinity. So we can see that their intersection is strictly this area right here. So that would be the domain for the addition, the subtraction, and the multiplication of f and g. Just those small intervals. So it'd be from, in this case it's from -6 to a -5, union 5 to 6. Oh, should have been a bracket because they're all inclusive. We have the last case where you divide the functions f and g, and the domain is still the intersection of the functions f and g, but we have to kick out anything that makes g equal to 0. So we never want g to be equal to 0, so g should never be equal to 0. So let's just do a quick look at what the actual function looks like when we write it out. It would be the square root of 36 minus x squared over the square root of x squared minus 25. So we want to look at this intersection, which we already know from this left part over here. We just want to kick out any values that make the denominator equal to 0, because we can never have the denominator be 0, or else our function would be undefined. So the values that make our denominator 0, we actually solved for them up here already. It's negative 5 and 5. So the way we can not include them on the interval is to just write the parenthesis when we write the interval notation. So it would be negative 6 to negative 5, parenthesis, union, parenthesis 5 to positive 6. So that's the same domain as adding, subtracting, and multiplying the two functions, but we kick out the values that make our denominator 0 in the case of division.